Everybody, Nick Dingle here again for the next video of VB.NET 2013. In this video we've got two things we're going to cover. The first is comments and comment blocks, and the second section we're going to cover decisions. Righto, and to get right into it, let's have a look at what a comment is. Welcome to my programming videos. Alright, that there is a comment. Everything you see that begins with an apostrophe is what you call a comment. And the idea of a comment would be, if you want to put in plain English what you're about to do, you put an apostrophe, which is this little baby here, and then anything that follows that apostrophe is completely ignored by Visual Basic. So it's for our eyes only. Okay, you can put as many comments as you want, and Visual Basic doesn't give a crap. Okay, they're really handy for a couple of things. First of all, they're really handy to just do what I'm doing here and just explain what's going on in the code, really. And the second way is, if you've got code that you think isn't working, or you want to test your program without a chunk of code, then you simply put an apostrophe in front of it, it becomes a comment and you can ignore it. So for example, if I've got this hello world here, and let's just change the foreground color to something like red, and I'll do a read line here, nothing special, so we've done that all stuff before. The first use of a comment, as I said before, would be to explain what code's going on. So, change the color and write to the screen. Alright, so that's a simple use of a comment, is just explaining what's going on in the code. As I said before, if I just run the program as a demo first, I'll show you the second use. There's a red hello world. That's pretty much all it's supposed to do. So if I don't want to change this color to red, let's say, if I put an apostrophe in front of it, it becomes a commented line and it does absolutely nothing. So the text is grey. And that's pretty much the two uses of just a single comment. Now, I notice that when I teach comments in class, there's two ways that students end up using comments. Not nearly enough, or way too much when they first begin. So preferably you would want to be one of the second people, the people who do it way too much. Because if you comment every line of code, you can then come back, and when you start getting a bit better at programming, you'll start to get a little bit of an idea of how much you comment things, how often you should comment, and how detailed your comments should be. So for example, commenting too much in this program, I can actually put a comment over here, which is known as an inline comment. I'll tab a couple of times, start here, change the text to red. I can comment down here, write hello world to the console. And finally, pause so we can see the result. So I could comment every single line of code in my programs. Okay, that's just an option that we have. But again, this is actually becoming a bit much. Okay, these are very simple lines of code, and if I really wanted to comment it, I would just keep the one I had before, change the color, and write to the screen. That's pretty much what I would get at. For every block of code that you have, I would add a comment in there like that. Okay, so we can get rid of these. Now, I also mentioned before comment blocks. All right, a comment block is where, let's say we want to explain what this entire sub is doing. All right, so what you do is you use the apostrophe again, but you don't do it one time, you don't do it two times, you do it 3 times. And you get a chunk called a summary and a remark. Now, these are quite powerful, but I can't show you the power of them right now. I'll have to show you that in a later video when we get into things like classes, which will be our 9th video, roughly. Alright, in this program, I want to demonstrate decisions. Whoop. And I've got to cut, wow, I can't type today. Notice how when I press enter, it just puts in another line for me. If it didn't start with this, Visual Basic wouldn't know it's a comment. Now, the first thing I want to do with you today, okay, number one, besides showing your comments, which is in progress, if you ask me. Okay, the second one I want to show you is if statements and selection statements. Okay, and what they are, they're also known as decisions. Okay, so we haven't started them yet. Third thing is we're going to look at nested if statements, just briefly. Well, actually, I've got that around the wrong way. Number 3 is actually going to be a demo of how you can use some if statements. The 4th one will be nested, and then the 5th one is going to be a new thing called set tasks, and I'll show that off right at the end. So this is one way you can use a comment block, is if you just got a lot to talk about, generally explaining a whole chunk of code, such as our submain, Okay, triple apostrophe, and as I said before, it's actually more powerful than when we're using it here, but I generally get my students to start using comment blocks to keep track of what work they're doing in their program. So, that's comments, and let's have a look at some if statements. Okay, I can type whatever I want in there, by the way. Okay, here's our little program. I'm going to kill it, dead, and let's have a look at an if statement. Now, an if statement, to explain it before I show it, is basically a programmatic question. Okay, so if you're doing your program and you realize that you need to ask the user a question, well, not even the user a question, just ask a question in programming. Let's say you want to check if what number the user typed in is a positive number, okay? Or perhaps you have a number guessing game and you need to check if the user got the number correct. Perhaps you have a memory match game where they pick two cards, and to see, you need to check if the two cards that they picked are the same, and if they are, they've got it correct. So it's a really good way of just basically saying that there's two outcomes in this case. Alright, in the number guessing game, you would say, yay, you got the number right, or no, you suck, stop playing. Things like that. Okay, so you've got one outcome if they get it correct and one outcome if they get it wrong. And this is where you would start to bring in if statements. Okay, so let's have a look at a really basic if statement. And it would just look like this. If 5 is less than 8, then let's write 5 is smaller than 8. And put a read line in, otherwise my program won't stay. This is probably the simplest if statement that I can demonstrate to you. Okay, and let's press play. Whoop. You'll notice it says 5 is smaller than 8, which is good. That's what you would expect. Okay, because in this case, 5 is smaller than 8, and it always will be. So it's a simple example, but it's not a good example because 5 is always smaller than 8, which means this instruction will always be executed. Alright, but what if we try the opposite of that? 5 is greater than 8. Alright, let's press play. Absolutely nothing comes up. We're stuck on the read line, so we have to press enter to exit. So this piece of code just got skipped over entirely. Alright, and that's because this condition is false. Alright, let me explain this to you, okay? Every if statement has what's called a condition. And the conditions can reduce down to a yes or no, or in programming terms we use true or false. Alright, if the answer to the if statement is yes, or the condition I mean, then we execute the code. If the answer is no, then we skip over this line of code. And you can tell which lines of code belong to an if statement or a selection because of this little indent and the fact that it's in between the if, then, and the end if. Alright, so for example, I can actually have more lines of code in my if statement. I can actually have whole chunks of code if I really want to. Right? You're not limited to just 1 or 2 lines of code, you have an infinite amount basically. And it's all based on this condition. If the condition is yes, also if the condition reduces to yes, we execute this code. If it's no, then it literally gets skipped over. So the if would go, if 5 is greater than 8, well it's not, jumps down to there. And then it keeps on going. Now this is, as I said, a bad example because the problem is every time I run my program, 5 is always going to be smaller than 8. And this condition is never going to change. So what we're going to do, let's set up a little program which asks the user for a number because it's always polite to ask first. Please enter a number. On the next line, let's get the number with our good old friend the read line. So dim a number and let's make it equal read line. And that'll make sure that we can get a number from the user. Because remember everybody that read line pauses the program and lets the user type in anything they want. Anything that's typed in while it's paused, then when they press enter, it gets jammed inside of num. So if I type in the number 10 and press enter, read line puts the number 10 inside num. Alright, so realistically I can go num is greater than 8 in this case. And we can change this to your number. And I'll change this to a less than again. Okay, back to what it was and go. So what we're saying is we get a number from the user. If their number is smaller than 8, then we say your number is smaller than 8. Wow, amazing, isn't it? Most people should hopefully know that. But let's have a look. If I type in 1, I get your number is smaller than 8. If I try again and type in 18, I get nothing. exactly what we should expect. However, let's expand this a little bit more. I used the example where we checked if the number is a positive value, okay? And this is where you have to start bringing in your understanding of maths a little bit, okay? This is where it begins. So basically, any number that is positive is greater than 0. So in this case, if I say, if the number is greater than 0, then you write your number is positive. Okay? And so this adds a little bit of like something interesting, I guess, to your program. It's a bit better than your number is smaller than 8, which is terrible. So enter a number. Let's go, what did I say before? Let's go 18 again. It's positive. Run the program again. -5. I don't get anything, which is perfect. That's what you want. So this line of code was skipped over. Now, this is pretty boring. What if we want to check if the number is positive? So really, we should probably check if it's negative as well and tell them all about it. So, and our rules for that one, we just simply put it here. You go, if num is less than 0, then write your number is negative. Whoop. Alright, let's try this program out. Enter a number, 18. Notice how it says your number is positive, but it didn't come up with the your number is negative, which is perfect. Run it again. -5, your number is negative. And in turn, didn't show me your number is positive, because the if statements did exactly what I asked them to do. Now there's one case, and you've probably already picked it up, where this will not, we're not checking, basically. We're not checking if the number is 0. So I don't get any messages. Because I'm saying if the number is bigger than 0, and I'm saying if the number is less than 0. Alright, so in that case, we're going to handle in just a moment. What we've got to do is make our code a little bit more efficient. Because basically, if the number is greater than 0, then there's no chance of the number being less than 0. So what's the point in having these separate? So what we do is we bring them together into one big if statement. So right now we have 2 singular if statements, and we can bring them into one. So if you get rid of this end if, forget the error, and instead of saying if, you put an else in front of this one. And there, what we have here today, everybody, is a binary decision. So basically, binary meaning two outcomes. There's our first outcome, and there's our second outcome. So it's a binary decision when it's only got 2 of them. So if the number is greater than 0, we write positive. Else, if the number is less than 0, we write the number is negative. Now, how is this more efficient? Well, basically, if the number we type in is, let's say, 18, 18 is greater than 0, so it writes your number is positive, and it will literally jump to the bottom of this end if. Okay, it won't even look at this line of code if this one's true. And the idea is you're actually saving the computer some time by skipping over this else or the if there and not performing it. Now I know that if they type in a negative number, it's going to have to check that one, and it's going to have to check this one, which doesn't make it any more efficient. But if it's positive, then we have made it a bit more efficient. Okay, so this one, now just to sum up, this is known as a binary decision because we have these 2 outcomes. And there is the possibility of adding more than 2 outcomes. Before we do, let's have a look at the syntax that we've just talked about in Mr. If statement. Alright, let's put it in a comment, if, and then condition. So remembering condition is anything true or false. Okay, then we can execute an instruction, and we can have an else if there. You don't need it, but you can. Then we can have another instruction, and then we have end if at the bottom. So that there, everybody, is the syntax for our binary decision. Okay, if you want that simple. And I should put that just down here, above the one that we've got. There's our binary decision. Now I demonstrated at the start of the video how to comment out lines, okay? And I'm going to comment out all this stuff because I'm going to extend this and we're going to use a different form of an if statement. Okay? This code will now be completely ignored by Visual Basic. Alright? Let's come down a little bit and let's look at what's called a multi-way decision. Right, the idea of a multi-way decision is if 2 conditions aren't enough, you need more than that, then you've got a multi-way. Alright, it just becomes one. So let's say we've got 2 conditions here, if the number is greater than 0 and if the number is less than 0, but we also need to check that last condition I talked about earlier, which is if the number is 0. So, in this particular case, let's do our if statement again. If num is greater than 0, then your number is positive. Don't like non-capitals. Whoa. Else, if the number is less than 0, then your number is negative. Wow, I'm going very well today. And then we've got one last case if the number equals 0. And we can write this a couple of ways. But in this case, we're going to go else. There's only one other situation. If it's positive, then we covered all of the positive bases. If it's negative, we've covered all the negative bases. Else, the number has to be 0, doesn't it? Your number is 0. And this is a multi-way because we have 1, 2, 3 different outcomes. Alright, and let's have a go at this program before we go anywhere. I'm a big fan of testing before you move on. Enter a number, 18. It's positive. Enter a number, -5, negative, and finally, enter a number, 0. Your number is 0. And there we go. So we've got that set up. That's perfect in my eyes. Okay, that's a multi-way decision. Okay, so the second version of the if statement I'm going to show you right now is we're going to have a program, and it's going to accept a number from a teacher, which is going to represent a student's mark from 0 to 100. And based on the mark that they put in, we're going to spit out whether that student got a pass, a fail, credit, distinction, or high distinction. So first of all, let's set up what the program's going to look like. So this chunk here, let's change this. So gets a mark from the teacher. So please enter a mark, and I'm going to change my variable name to mark as well. Okay, now what we need to do is check the mark they typed in. And what are our different conditions? Well, basically, let's have a look at the different conditions. If a person gets a mark from 0 to 49, say, that's a fail. If a person gets a mark from 50 to 64, bear with me, it's a pass. If they get from 65 to 74, it's a credit. And we just keep on going. 75 to 84 is a distinction. Then we've got 85 to 100 is a high distinction. Now, we're not actually done here because we're checking all the cases we would like. What about the cases they could possibly type in? So what I mean by that is, what if they type something less than 0 or something greater than 100? All right, they could even type in a word, but that will crash our program, and we have to use error handling for that. If you don't know how to do error handling, go back to the third video and have a look at user input. All right. Now, in this particular case, if they type in anything else, it's an invalid mark. So that's what we're going to do for this one. Let's start with our if statement. Let's go if mark. Now, the first thing we want to check if it's greater than or equal to 0. And we're going to check everything from 0 to 49. So we can go if the mark is greater than 0 and mark is less than or equal to 49. Then what happens? Well, they failed. That's just it. Then the next set of case is 50 to 64. So else if mark is greater than 50 and mark is less than or equal to 64. And then in that particular case, they passed. And we just keep going in this fashion. So we're making a multi-way decision with lots and lots of conditions here. But this is basically how we want it. So 65 and the mark is less than or equal to 74. I'm just going to finish this up quickly. Wow, fast typing. Stuffing it up royally. Okay. Okay, so that's set up. That's looking pretty good. We're covering all of our normal bases. We just haven't covered the anything else. Now, we can just use the else at the bottom, which is lovely. So we're checking everything from 0 all the way up to 100, and anything else is an invalid mark. And that's literally all you have to do in this case. So if I press play now, let's have a go at this program. Again, test it. You always really should test every single possibility. So you should test a fail, pass, credit, distinction, and high distinction, and an invalid mark. And you should test all the marks on the in between and the boundaries and stuff. But for example's sake, let's type in 5. They failed. -5, invalid mark. 55, it's a pass. Keep on going. 105 is an invalid as well. And 100 gives us a high distinction. I could keep going all day, but I'm sure you're pretty bored already with it. So that there is a very long multi-way decision, and the else, by the way, can only appear once at the bottom. I'm covering my bases here for fail, covering my bases here for pass, and so forth, all the way down. And anything else, we need to consider it as an invalid mark. So that's why you put else once at the bottom. And that's how that appears. Alright, if you want to have a go at that, pause the video, type it down and test it out. But for right now, I'm going to wipe this and we're going to try a menu system. So, select, delete. Now, let's step into the next form of decisions. We're going to have a look at a selection statement. Alright, the syntax. Select case, and variable name. Then we go case, a value. Then we have instructions for that value. Then we can have case, the second value. Then more instructions, and then we can have at the end and select. Okay, that's the syntax for it. Very similar to what we have with the if statement, except for we had number greater than 0, for instance. In a select case, you would have number greater than 0. So the conditions sort of split up into two pieces. Bear with me though, we're going to get this done. So, in this program, what are we going to do? We are going to get a menu item from the user and check what they selected. Okay? So, first of all, we need to actually draw the menu. So, lots of right lines here, everybody. Apologies. I'll be quick. I try. Select from the following. Okay, based on that, let's go the letter A. Oh, stop doing that, Visual Basic. Letter A, they've selected apples. I'm copying and pasting, by the way, everybody. Apologies if it's too quick. For the letter B, they selected bananas. For the letter C, they selected carrots. And let's leave it at that. And let's give them a nice little right. Whoa. Their choice is something. Now, in another video, previous video, I showed you how to use what's called a read key instead of a read line. And I'm actually going to bring it into play now. So first of all, I need a variable to remember their menu selection, and I also need to get their menu selection. So we're bringing in two pieces here, like we did before. I like to call it selection, the variable that is, and it's going to be as a character, because I want to select A, B, or C at a time. And that equals a read key. However, as I showed in the last one, we can't just use .read key. You have to use .keychar at the end. So that's getting their choice on this line. Okay, if you don't understand what that line does, you need to play around with it a lot. Try to break it, try to fix it, try to do lots of different stuff. Okay, time to bring in what they selected. Check what they selected. Alright, so bringing in this syntax, we have select case and the variable name. Well, I know my variable name is selection. Okay, so let's type that. Select case, selection. Notice it put the end select in for me, which is fantastic. Case, and then the first value. So in this type, we got case, and then you've got the first one is the letter A. So make sure you put quotes around it, because we're checking if it's actually the letter A. Okay, so if they typed in the letter A, they love apples. So let's go console right line, you love apples. What if they selected B? Well then you love bananas. Last one, if they selected C, you love carrots. And then finally, what if they selected something other than A, B, or C? We've got to cover all our bases if we can help it. What if they selected D, or the number 9, or a semicolon? Well, just like the if statement, we have a case, else. Okay? And in this case, well, let's say they typed in something other than what we wanted to, so you love nothing. That sounds pretty harsh. But anyway, there's our program in a nutshell. You love apples, you love bananas, you love carrots, you love nothing. So, starting this program up, and I type in A, I love apples. I hate the way that appears up there, okay? I'm going to quickly change that by doing a console write line here with nothing in it. There we go, pops on the next line. What if we do B? Bananas, carrots, and 5. You love nothing. And there you go. That's how you can create a really simple, easy to use menu system. It's pretty straightforward. It's not hard to use at all if you ask me. Okay, but there's one little issue with it right now. And the issue would be, what if they've got caps lock on and they're typing this in? So I'm asking them for a little a, a little b, or a little c. What if they type in a capital A? Well, they love nothing apparently. Well, really, they love apples. And we need to take that into consideration. So what we can do to our select case is you can actually add another case just here. If I go, the cases for apples is a little a or a big A. So if I try this now, type in a big A, I love apples all of a sudden. So what actually that means is these three belong together. Case A and case A, you love apples. So I need to do the same thing for these. Case B, they love bananas. Case C, they love carrots. So in this case, haha, pun, it'll work. Anything else will still produce you love nothing. F will produce you love nothing. Capital F, you still love nothing, because that's a very sad person. Okay, that's a select case, everybody. And I'm going to show you one last thing before I let you go. And well, no, I'm actually going to show you two things, and then I'll let you go. The next one, pause, bloody hell, I'm losing myself. So, pausing for a second. If you would like to try that program yourself, pause the video, have a go, because I'm about to delete this, and we're going to look at what's called a nested if. So I'm deleting it now. Okay, and what is a nested if statement? Well, it's actually simpler than it sounds. A nested if statement is an if statement with an if statement on the inside of it. And that's pretty much the concept of it. 5 is small, and so is 1. Alright? You'll notice that line of code still gets executed even though there's two if statements. So you'll notice that this if statement, well, this line of code belongs to this if statement belongs to this if statement. So if there's one if statement inside of another, it's known as a nested if statement. And you can do this as far down as you want. You can indent it more and more and more. So you might ask me, well, how is that relevant in the real world? Let's go back to our original idea of asking the user what number they want to type in. So if I just quickly write that back up, please enter a number, and then dim num as integer equals console.readline. Right, let's say we wanted to check if the number is positive. If it's a positive number, we're going to check if it's even or odd. There's a nice little trick we can do with this. And if it's a negative number, we're not going to check if it's even or odd. So, first things first, positive or negative. So if num is greater than 0, so it's the exact same thing as we did before. Wow, I can't type this afternoon. Console.writeLine. Your number is positive. Alright. Else if number is less than 0, then your number is negative. And then finally, let's put in the else case for if it's 0, your number is 0. Okay, so if the number's positive, I want to check if it's going to be an even or an odd number. So just here, I'm going to have a nested if statement, because I don't want this if statement to execute if it's a negative or if it's a 0 number. I want to check if it's even or odd just here. Now, how might you do that? Some people will know the answer straight away. Some people won't. Doesn't really matter. It doesn't show that you're dumb or smart. What it is a nice little trick. If you've got an odd number and you divide that by 0, divided by 2, you'll get a 1 remainder. If you take an even number and divide it by 2, you'll get no remainder. So, how do we check the remainder of a division? Well, we used our mod arithmetic operator from the last time. So if I go num mod 2, we're dividing by 2 but looking at the remainder. If that remainder is 0, then the number is even. Your number is even. Else if we divide it by 2 and get a 1 remainder, well, it must be an odd value. So there's our nested if statement because it's nested in this big one. Excuse me. Let's type in 15. It's positive and it's odd, which is perfect. And 18, it's positive and it's even. Okay. That's pretty much it for if statements this time around. Use them more and more. You're going to have to practice the hell out of them because if statements are extremely important for just adding a good version of your, well, adding interactivity and adding a little bit more depth to your program. One last thing before we go is I'm going to quickly show you what's called a set task. And I give this to all of my students, and I'm going to have links to these set tasks in my videos in the description. So, all of these set tasks have different, well, they have different programming skills underneath them. The first set task was the one about console commands. The second task is about variables. The third one is the one we're up to. Each one of these programs uses if statements in different ways. So for the first program, we've got how old are you? So I can go 15, but I'm not old enough to vote. Done. Run it again and type in 21. I can vote. Fantastic. Well, realistically, what I get my kids to do is make a VB project and try to reproduce these programs as close as possible using the skills that I just teach them. So for this case, I would make them use if statements. So the second program, ultimate number check, we pretty much just did. If I type in 10, it tells me it's positive and even. Alright, so I've pretty much done that one already for you. Well, I have done that one already for you. The third set task is an area calculator. And this one always seems to get kids because it's using variables, console commands, and if statements in a big way. So, for instance, if I click A for square, what's the length of the square? Well, let's say it's 15 meters. That means my area is 255. And you can do that with multiple shapes. Circle 4 tells me my radius is, my area with the radius 4 is 50.26 and so forth. Okay, so I'll give you links to those programs in the video. Test out your if statement abilities, try to understand it before you move on to the next video, and good luck everybody, happy programming, and see you in the next video.